Absolute value. Copy the title. We're going to see the theory for absolute value. What is absolute value? Absolute value is a function. As I mentioned in the topic of functions, most of the operations we work with are functions. So addition, subtraction, exponents, roots, they're all functions. So in this case, as any function, you have an input and you have an output. And in the case of the absolute value, the output is always, no exception, always 100% of the time a positive value. This is very important. It's just the definition of the absolute value, and I want you to copy it, pause the video, copy, and I'm going to continue with the definition. Okay, so what is the definition of an absolute value? What is an absolute value? Well, as I said, the absolute value is a function that gives always a positive result as an output, which means if I input a positive number, a is greater than 0, then the absolute value of a is going to be a, which means if I input a positive number, absolute value of 3, the answer is just going to be the exact same number. If the input is a negative number, then the output is going to be the negative of that, which means if my input is negative 3, then the output is going to be negative 3, therefore making it positive 3. The output, as I said, is always positive. Now, how do we use this in an equation or in a question for absolute value? Well, if they tell us something like this, absolute value of a is equal to b, then we have two solutions. Solution 1, we take the positive value, and solution 2, we take the negative value. For example, if I say absolute value of x is equal to 3, this means that I have two possible values for x. Either x is 3 or x is negative 3. If you think about it, you may remember that this also happens when we have a square. So x squared is equal to 25. So x is either 5 or x is equal to negative 5. If they don't give you any restrictions, you have to take both values. Pause the video right now, copy everything, and we're going to move on. Okay, what about the graphs of an absolute value? Well, the graph of an absolute value, since the output is always going to be positive, means that we are not going to consider the negative values for the y. We're not going to consider negative values for the output. Remember, the x is the input, the y is the output. So, for example, in a regular equation, when I have y is equal to x, like for every value of x, I have the same value of y. So 1 with 1, and we have negative 2 with negative 2, right? But in the absolute value, when I plug in 1, I'm still going to get 1. But when I plug in negative 1, I'm also going to get 1, which means this function is going to be like a linear function reflected on the x-axis because it's never going to touch the negative side of the y-axis. Is it going to touch the negative side of the x-axis? Yes, because remember, the x is the input, the y is the output. Pause the video, copy all of this. We are going to move on. How do we solve equations with absolute value? Well, we just pretty much use the definition. If you remember definition, that's pretty much all you need, but we're still going to explain. So we have absolute value of x plus or minus a is equal to the outside value. So we take both cases, equal to the positive or equal to the negative. In this example, I have absolute value of x plus 5 is equal to 3. So I have case 1, taking the positive value 3, case 2, taking the negative value, negative 3. If I solve the first case, I have x plus 5 is equal to positive 3. So x is equal to 3 minus 5. So x is equal to negative 2. That's one answer. In the second case, I have x plus 5 is equal to negative 3. So x is equal to negative 3 minus 5. So x is equal to negative 2. To negative 8. This is my second answer. Both are answers for the same equation. Pause the video right now. Copy if you have to copy. We are going to continue. What about inequalities? How do we solve inequalities? Well, this is extra information. This is not exactly the same as solving an equation. So we have two cases, right? So if I have absolute value of a is less than or equal to b, I still have my positive and my negative, but I'm going to switch the sign, the symbol. For example, if absolute value of a is less than or equal to b, so I'm going to take the positive b, and I'm going to keep the sign less than or equal, less than or equal. But in the second case, I'm going to switch the sign. I'm going to use negative b, and I'm also going to switch the symbol, greater than or equal to negative b. So if I have absolute value of x is less than 3, then I have two cases. X is less than 3 or x is greater than negative 3. This happens because if you think about it, I'm looking for the result to be less than 3. So I have my number 3 here, negative 3 here, and I'm looking for all the values that are inside this range, from negative 3 to 3. So if, for example, if I have negative 2, the absolute value of negative 2, which will be 2, is less than 3. But if I take negative 4, which is outside the range, then absolute value of negative 4 will be positive 4, which is not less than 3. So I take the range from negative 3 to positive 3. On the second case, when I have greater than or equal to, I have greater than or equal to the positive, or again, I switch the symbol for the negative. So I have my example. Absolute value of x is greater than 3. So case 1, x is greater than 3. Case 2, x is, disregard this, less than negative 3. So I have negative 3 and 3. And in this case, I'm not going to take the range of intersection or the range from negative 3 to 3. I'm going to take the opposite values. Okay, pause the video, copy this. We are going to move on. Solving inequalities, again, in this case, we apply the same principle. You can copy these 2 points, but we're going to solve the exercises. I have absolute value of x plus 5 is less than or equal to 3. I have my first case with the positive, same sign, same symbol. The second case with the negative, I revert the symbol. So x plus 5 is less than or equal to 3, so x is less than or equal to 3 minus 5, so x is less than or equal to negative 2. In the second case, I have x plus 5 is more than or equal to negative 3, so x is more than or equal to negative 3 minus 5, so x is more than or equal to negative 8. And I do the same for the second case. I want you to pause the video right now, copy everything that you see on the screen, and we're going to move on. Keeping with the inequalities, this is a principle of inequalities for the absolute value that you can use. If you want to, you can memorize it, but if you don't memorize it, it's okay, because you can always just do it from scratch using the definition. So when they say that a value is greater than a and less than b, you can create an absolute value using those values with this form. Absolute value of x minus the half of the addition, which is less than half of the difference. For example, Liz wants to buy more than 50 apples but less than 120 apples, so the number of apples will be absolute value of a minus half of the addition. The addition is 170, half of it is 85, and which is less than the half of the subtraction is 70, half of it is 35. You can do this if you remember, but if you don't, my advice is just you try alternative by alternative, because if you open up this absolute value just using the definition, again, this gets you 2 cases, right? The positive and the negative. So we're going to work with the positive and with the negative. So first, let's take the positive. So I have a minus 85 is less than 35, right? And then I have the negative, which is a minus 85 is more than negative 35. I'm going to continue solving. So for the positive, I have a is less than 35 plus 85, so a is less than 120. And in the second case, I have a is more than 85 minus 35, so a is more than 50. So you can work this from the alternatives and open up or expand each alternative until you get the case that you want. So you can always check this. You don't really have to memorize this. It's just, if you do memorize it, it's an easy way to solve this type of questions. Pause the video right now, copy everything here, and we are going to move on. We're going to start with this example over here. Pause the video, solve this question, write down your answer, and we are going to check. Okay, how many integers values satisfy this? Absolute value of x is less than 4. Again, we apply the definition, means that either x is less than 4 or x is more than negative 4. So we have this range from negative 4 to 4. So we count how many integers we have. So we have negative 3, negative 2, negative 1, 0, 1, 2, and 3. So we have 1, 2, 3, 4, 5, 6, 7. I have 7 numbers, 7 integer numbers. Copy this. We're going to go to the second example, pause the video, solve this example, and we're going to check how many integer values satisfy this. Again, we just solve it using definition. So absolute value of x plus 1 is less than 5. We have case 1, case 2. Case 1, positive. X plus 1 is less than 5. Case 2, negative. X plus 1 is greater than negative 5. So here I have x is less than 4. Here I have x is more than negative 6. So I have my range from negative 6 to positive 4, and I count how many numbers I have. So -5, -4, -3, -2, -1, 0, 1, 2, and 3. And I count 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 integer values. Pause the video, copy this, and we're going to move on. Okay, pause the video right here. This is a graph of absolute value. Solve this question, write down the answer, and we are going to check. Which of the following could be the graph of this? Now, this is an absolute value, or the graph of an absolute value. And remember, the absolute value never takes negative values for the y-axis. So just by knowing that, we can know that the answers cannot be A and cannot be B because they're taking negative values of the y-axis. I can also know that since this is the absolute value of a line, this is not a quadratic, I'm just going to reflect on the line, which means I'm not going to choose letter D. A way of doing this will be like you can just create the line. This is like the typical line. And then you reflect on it because you're not taking the negative values. So the answer will be letter C. Pause the video, copy if you have to copy, and we are going to see the application questions from the Digital SAT. Pause the video here, copy this question, solve this question, and we're going to check. Okay, here the question is, do we have also value of this? And they're asking me for the positive value of x minus 1. This is important because they're not asking me for which values, just for the positive value. So I don't really have to do the negative value. I'm just going to focus on the positive. So I have 4x minus 4 is equal to 112. So here I'm going to use a trick because they're asking me for x minus 1. They're not asking me for x. So I'm just going to factorize. I'm going to put 4 times x minus 1 is equal to 112. So x minus 1 is equal to 112 divided by 4, which is equal to 28, which is the answer. Now, let's say I don't really quite got how you, I didn't quite get how you factorize. So, like, you're going to say, I don't understand the factorization. Don't worry, you can still solve it with a regular equation. So, we're here, right? 4x minus 4 is equal to 112. Okay, so 4x is equal to 116. Okay, so x is equal to 116 divided by 4. Okay, so this is going to be equal to 29. And then you're going to say, but isn't the answer 28? Well, yes, but x is equal to 29. The question is not about x. The question is x minus 1. So what you have to do is do 29 minus 1, and that is equal to 28, which also gives me the answer. Okay, pause the video, copy this, and we're going to move on to the second question. Pause the video right now, solve this question, and we're going to check. Now, in this case, unlike the previous question, this is asking us for one possible solution. This is not asking us for the positive or the negative solution, which means we have to find the solutions. But since this is a grading question, which means we have to provide the answer, all we have to do is find one solution, which means you can choose the positive or choose the negative. Both will be right. I'm going to do both. So I'm going to put case 1 and case 2. Case 1, the positive. So x minus 5 is equal to 10. Case 2 is the negative, so x minus 5 is equal to negative 10. If I finish solving this, then x is going to be equal to 5, which is one solution. In this case, x is going to be equal to negative 5. Sorry, this is not 5, this is 15. 10 plus 5 is 15, which is one solution. And in second case, x is going to be equal to negative 5, which is another solution. Both are correct solutions, so you can just focus on one and solve for one. Okay, pause the video, copy if you have to copy. This is all the theory you need for the absolute value. Most of the absolute value questions can be solved just with the definition. Here are the chapters or the pages from the Panda book and the Varus book where you can look for more practice. And we are going to continue with the math theory.